Hey guys, this is the notes for 7.3, and 7.3 deals with proving triangles similar. We'll learn about a couple theorems to prove similarity. Okay. The first thing it starts off with is solving proportions by cross multiplying. So this is a warm up. Right, 10 times 10, we cross multiply. Right, we get 100 equals 8n. So therefore n equals 12.5 when you divide both sides by 8. Cross multiply here, we get 3n equals 2 times n minus 3. Cross multiply here, we get 5 times r plus 5 is equal to 8 times r minus 9. All right, so just cross multiply to solve proportions, right? If you want to finish these out, n should be -6. All right, and then r should be about 32.3 repeating. Okay, if you solve both of these. I'm not going to fully go through them because you should know how to solve proportions by cross multiplying. So now we're going to go through the theorems. So the first one is angle. So this tells us if two angles in one triangle are congruent to two angles in another, then triangles are similar. So if two angles in one triangle, I'm going to abbreviate, are congruent to two angles in another triangle, then they're similar. All right, so you can see in the picture, right, we see A and D are congruent and B and E are congruent. Therefore, we can say that these two triangles are going to be similar. So ABC is similar to triangle DEF. Remember that little tilde is the similarity symbol. Another theorem is the side. So this tells us if corresponding sides of two triangles are proportional, the triangles are similar. So corresponding sides of two triangles are proportional, then they're similar. All right, so you can see we're given that AB over DE is equal to BC over EF, which is also equal to AC over DF. Okay, so it's just saying the sides are proportional. Then we can say that these triangles are similar. Right, so triangle ABC is similar to triangle DEF. And then the last theorem is side-angle side. Okay, so this tells us is if an angle in one triangle is congruent to another, and the sides including the angle are proportional, then the triangles are similar. Okay, so if an angle in one triangle is congruent to the other, and the sides including, right, the angle are proportional, they're similar. Right, you can think of it like side angle side, right? We can actually mark the sides if you want. They show similarity, right? So AB and our EF, sorry, AB and DE. Sorry about that. All right, and then BC, I'll make 2 squiggles, and EF. All right, we can say the triangles are similar. Now we'll look at an example where we can use these different similarity theorems. So this first one, right? First, we need to figure out which sides are proportionate to which sides. Right. So if we look, let's first match up what side matches with 3. Right. It should be 4.5. So we'll set up that proportion, 3 over 4.5. Right, and this should equal another proportion. So 5 to 7.5. Right, which should equal another proportion, 4 to 6. Right, so what we can do is figure out if they all simplify to the same exact ratio. So, all right, let's change this to 10 over 15. All right, to get a whole number, we'll change this to 6 over 9. And then we have a whole number 4 over 6. And then we can see they all reduce to 2/3. Right, so since they all reduce to 2/3, that means all 3 sides are proportionate. Therefore, our triangle ABC is similar to triangle DEF, right, by the side theorem, right? So the side similarity theorem. All right, so now let's look at B. Right, we're given 2 triangles, right? PQS. So that's this whole triangle. And we're trying to find out if RQP, the smaller triangle, is similar to that. Right, so one thing we can mark is that they both share angle Q. So that's one thing we can mark, right? So angle Q is equal or congruent to angle Q, right? So we know that because they both share that angle, right? So since we have an angle, right, but we only have one angle, let's look for proving SAS, right? Since we have one angle, right? We have angle, side, and side angle, side, right? The only one with one angle would be side angle, side. So we want to look to see if we can prove that. Well, we want to use the order similarity statement to set up these proportions. Okay, so, right, we know PQ should go along with RQ, right? Because PQ and RQ are both the first 2 letters in our triangles, right? And that should align with SQ, right? So the last 2, and PQ. Right? Those are the last 2 letters of the triangles, right? So let's see if they're proportionate. Right, so let's set up the proportions. We given 18 for PQ, RQ is 12, SQ is 27, right? Because we add 15 and 12 together to get that 27 for that whole SQ piece. And then PQ is 18, right? Now, if we look, they both are going to reduce to 3 over 2. Therefore, right, that's true. Therefore, we have 2 proportionate sides and an included angle, right? So these two triangles are similar. PQS is similar to triangle RQP by the side angle side similarity theorem. The next set of problems is finding the value of each variable given that the triangles are similar. Okay, so we just need to set up proportions. Right, so we should know that 20, right, and 35 go together, and B and 21. All right, so we'll set up the proportion 20 over 35, right, and that's equal to B is written first because we wrote 20 first, right? So see how both the left triangle is on top, right, and the right triangles are on bottom, right? The right triangle pieces. Now, right, what we want to do is multiply out, right? So we get 35b, right? Cross multiply is equal to 420. And when we divide both sides by 35, our b is going to be equal to 12, right? So b is 12. And then we can see these angles are going to be congruent by the fact we know the triangles are similar. That means the angles are going to be congruent. So angle A's degree is the same as that 94 degrees. Let's look at another example, right? We're given that 25 is KC, and then 107 actually represents this whole piece. Okay, so 107 is KM. KC is 25. All right, so we'll set up the proportion, right? We know the first triangle, right? We don't know KB, right? So we can set it as X or KB. It doesn't really matter, right? So X over, right, its corresponding side would be 88, right? And then 25 is from our small triangle to 107. We cross multiply, we get 2200 is equal to 107x, right? We know x represents KB. And then when we solve for x, we should get about 20.56. So x is approximately 20.56, or KB is approximately 20.56. So that's what we were looking for. We were looking for KB. All right, this next example, they're similar. So we're looking for angle L, right? So we're given that the triangles are similar, right? So all the angles are congruent, right? So this is 100, this is 35, right? So to find angle R, right, it's just 100 plus 35 plus angle R equals 180, right? Because all three angles added together give you 180. So angle R is equal to 45 degrees. And we know by triangles being similar, that means their angles are congruent to each other, the corresponding angles. So if angle R equals 45 degrees, then that means that angle L, the measure of angle L, is 45 degrees. And then the last one we're going to look at, right, is we want to state if the triangles in each pair are similar, and if so, complete the similarity statement. So we need to prove they're similar. So we're given, right, these are the angles, right? And then 21 needs to be similar to 9, and then 18 and 42, right? So they correspond with each other. So we just need to make sure that this proportion is correct, right? So 9 matches with 21, and 18 matches with 42, right? So if we cross multiply, we get 378 is equal to 378, right? Because 9 times 42 is 378, and 21 times 18 is 378. They are true, right? They are proportionate. So therefore, we can say triangle FGH is similar to triangle UVW. And that's all for 7.3. If you have any questions, let me know on Remind or Google Classroom.